All right, in this video, we're going to be talking about section 3.2, which is about logarithm functions and their graphs. I'm going to try to go through this pretty quickly. So, as warm-up, we are going to practice graphing a few exponential functions. So let's do that very quickly. When we graph y equals 3 to the x, the intention is that we do not need a table of values, but that we know the pattern. So I know that x is 0, we've got 1, and x is 1, we've got 3. And if I wanted to go to the next one, I'd be at 2, and I'd be up at 9. So this is the point 0, 1. This is 1, comma 3. And if I did the next one, it'd be 2, 9. If I did another one, it'd be 3, 27. But I want to see 3 points. This one, oh, my clicker's not working. 1, 3, 0, 1, and this point right here, which would be negative 1, which flips over the 3 and makes it a third. All right, when we do B, we're still going to have that same basic picture, but this time it's going to be shifted over because we have changed the x into x plus 2, which means we're going to shift to the left. So I'm going to just take this picture, and now I'm going to make this my x and y axis. And then I'm going to draw that exact same picture, which I guess I never actually drew. Horizontal asymptote. So I have a horizontal asymptote still at 0 because I didn't move it up or down. This is going to be 1 up. This is going to be over 1 and 3. It's going to be over 1 and a third. So the exact same picture, just shifted over 2 units. Should not need a table of values. On the next question, we've got a lot more going on here, but it's still the same basic picture. It's still coming from y equals 3 to the x. So this one is going to shift down 4. So I'm going to give myself a little room to shift. All right, so we're going to shift negative 1, so to the left 1 and down 4. 1, 2, 3, 4. So I'm going to make myself a little fake x and y axis. My horizontal asymptote is right here. All right, so we've taken care of the shift 1 and the 4. So now all I'm really going to do is, instead of graphing y equals 3 to the x, I'm going to do y equals 2 times 3 to the x. And we know that multiplying by a 2 on the outside here is just going to double the outputs, right? So it was going to be an answer of 1, right? So it would have been here, except I'm doubling it. So we're going to be up at 2. Oops, except I'm in the wrong spot. Let me move over. Sorry about that. Normally would be on the y-axis right here. And again, this is my fake axis. This is not an asymptote I'm drawing here. It's just a graphing aid. So normally at 1, but I doubled the height, so it's going to be at 2. I would normally be over 1 and up 3, so now it's going to be over 6, up 6, excuse me. 1, 2, 3, 4, 5, 6. Normally I'd be over 1 and up a third from here, but now I'm doubling that, so I'm going to be up 2 thirds. And so most of these points will be just like we can count and label them, right? So this is the point 0, 2. This is the point negative 1 and negative 2. But this one here is going to be a little bit trickier. It's at negative 2, comma. And then we know we're up 2 thirds right there. And so that means I'm down 1, 2, 3. And then I'm a third more to get to the 2 thirds. So we're going to be at negative 3 and a third. All right. So that we have already covered. That was from section 3.2. So today we're going to be covering section 3. This is 3.2, excuse me. And so today we're going to be covering, another graph here. This one's trickier. And the tricky part comes because of this negative right here. All of our rules for shifting only work if the leading coefficient is negative. And so I need to factor out a negative 1. So that becomes negative 1 times now positive x minus 3 plus 4. So I have a couple of ways of handling this. One way would be to realize that a negative in the exponent is just going to reflect it, but this time it's going to reflect it across the y-axis. So just as a quick aside, if I were to graph simply this problem, then my graph that was going to look like this gets reflected over and is going to look like this. Okay? But I would suggest that we handle it a different way. Since the 3 is being raised to the negative 1 power, we could just rewrite this problem and make it negative, and then 3, oh, not 3, the negative takes its reciprocal. And so let's just turn it into 1/3. And now let's graph that. So let's kind of map out what's going to happen on this. Obviously, I'm going to shift it around, but 1/3 to the x is going to look like this. And then I'm reflecting that over the y-axis, and so it's going to look like that. So this is the picture I should get just in the right spot. So let's go find the right spot. Move over 3 and up 4. So that's going to put me right here. So I have a horizontal asymptote at y equals 4. Okay, so normally I was going to be a picture up here, but I'm going to reflect it over. So what's that going to look like? Normally I'd be up 1. This time I'll be down 1. I would be at over 1 and I'd be at 1/3, so now I'm going to be at 1/3 there. Normally I'd be over 1 and up 3, so now I'm going to be over 1 and down 3. And so I get my graph that looks like this-ish. Okay, and notice it matches the picture that I drew over here. So once again, we normally had 3 to the x. The negative made it 1/3 to the x, and then the negative out front reflected it to that. All right, let's move on. Okay, so how do we solve an exponential function? So 10 to the x equals 10, and all we would do to solve that is just think it through. And I know that x equals 1, because 10 to the first is 10. 10 to what power is 1? That would have to be 0. 10 to the third. Flipping a 10 over to make it 1/10 would happen if x was negative 1. And then 10 to what power equals 80? Ooh, that one doesn't really work out quite as well. I know that 10 to the first is 10, and I know that 10 squared is 100. So my answer has to be somewhere in the 10 to the 1 point something power. This problem, and technically all of these problems, are why we have logarithms. So if you recall from Algebra 2, logarithms are the inverse functions of exponents. So we have these statements right here. An exponential form shows the base raised to an exponent, and that equals the answer. So a to the b equals c. A logarithm will take that same exact problem and rearrange it. So the logarithmic version of this would be log base a of c equals b. So what you'll notice is in our exponent we had a base a, in our logarithm we had a base a. This problem we have a b as our exponent and c as the answer. So in this problem the b and the c change places. So let's rearrange this as a logarithm. So 10 to the x equals 10. So that would be log base 10, and then we grab the 10 of 10 equals x. So notice how rewriting this exponent as a logarithm took this unknown exponent and placed it squarely out here by itself as x equals. So when I go to answer this question, log base 10 of 10. Well, here's what's going to seem kind of silly. In order to answer this question, I'm actually going to think about it back how we thought about it originally and just ask myself, this is just meaning 10 to what power is 10? Oh, x equals 1. So in a lot of ways, it seems silly to even have logarithms if we're just going to answer them based on the original question. But I want you to notice this is not a new phenomenon. For example, if I asked you for the square root of 16, how are you answering that? You're not doing any specific math. You're just searching your mind and saying, hey, wait a minute. This is saying what number squared is 16? Oh, the answer is 4. So notice you didn't really answer this question. You answered this question, the inverse. And you thought about it and said, ooh, 4 squared, right? So this is exactly the same thing. In order to answer a logarithm, we'll often answer it based upon the question it came from. So 10 to the x equals 1. If I'm going to rewrite that, it's going to be log base 10 of 1 equals x. And what is the answer to that question? Again, this will be more familiar pretty soon. But in order to answer this question, I'm really going to think about the original question. 10 to what power is 1? That's what this is asking. 10 to what power is 1? And the answer would be 0, just like we did a second ago. This is going to be log base 10 of 1,000 equals x. And then log base 10 of 1,000 is 3. Why? Because 10 cubed is 1,000. Log base 10 of 1/10. I'm sorry, I don't know why I said that. I was thinking of something else. 10 to the x equals 1/10. So I'm going to say log base 10 of 1/10 equals x. What does that mean? It means what it originally said. And then we think about it and we're like, oh, x is -1. And then we get to this one, which would be log base 10 of 80 equals what? And now we finally see why a logarithm is useful, because at this point, I'm going to grab my calculator and I'm going to answer this question. And so if you look at your calculator, and I'm sorry I don't have my calculator ready to show up on the screen, on your calculator is a log button. And so I go find that log button, and the log button on your calculator, you'll notice it just says log. It doesn't say log base 10. We'll talk about this later, but that means log base 10. So it's the log on your calculator is base 10. So I'm just going to hit log of 80 and hit enter. And it gives me that x is approximately equal, because it's always going to be an irrational number, 1.903. And again, that matches pretty close to what we thought. We knew it had to be between 1 and 2, and definitely closer to 2. All right, let's keep going. The goal of this lesson is really just to get comfortable with this conversion back and forth. So convert between exponential and logarithm form. We know that 3 to the 4th is 81. And if I wrote it as a logarithm, it would be log base 3 of 81 equals 4. 3 to the 4th is 81. And honestly, I'm a little bit less comfortable going one direction than the other. I'm more comfortable moving out of logs and into exponents. So anytime I do it the other way, I always reverse it in my head and just check. So after I write it down, 3 to the 4th is 81. Got it. Part B would simply be 10 to the 4th equals 10,000, which is true. 10 to the 4th is 10,000. This one, 7 to the 3rd is 343. I could write as a log. Base 7 of 343 is 3. 7 cubed is 343. And log base 4 of 16 is really just saying 4 to the 2nd power is 16. All right, so once again, our goal here is just to get comfortable. Example 3, let's evaluate these logarithms. So honestly, you're going to, by the end of this chapter, and maybe even by the end of this homework assignment, you're going to be able to really do these very quickly. So I look at this question and I know automatically the answer is 3 because I'm getting to a point much like square roots where I don't have to think about the square root of 16. I just know it. So this for me is obviously 3. Now, why is it obviously 3? If you need to, put it like an implied little equals what here. And so this is saying 5 to what power is 125? And that is 3. 5 times 5 is 25 times another 5, 125. I'm going to do part C first, log base 3 of 0. So that's asking 3 to what power equals 0. And now I'm confused. I was going to say like 1 because I know that 0 and 1 and exponents are all related, but that's not correct. 3 to the first is 3. And if I start thinking about my graph of y equals 3 to the x, I quickly realize, wait a minute, we have an asymptote at 0, meaning I'm never equal 0. 3 to the x cannot ever equal 0. So this one has no solution. And the other kind of obvious answer is 3 raised to a power. The answer is always going to be positive. There's no way to get it to be 0. All right, this question, a little bit harder to do in my head, even at this level that I'm like kind of getting comfortable with them again. So I'm just going to rewrite it. So I'm going to put an implied equals x over here. And so this is 1/4 to what power is 16. All right, I can turn a 4 into a 16, and I can flip a 1/4 over. And so I think x should be a negative, and that makes it 4. And then if I square it, it'll be 16. -2 would be the answer. All right, and I should technically put that in parentheses. All right, this question, log base 2 of 2 to the 8th, may look crazy, but honestly, by the end of the chapter, you're going to know instantly that this is the answer, 8. Because what is this asking? 2 to what power equals 2 to the 8th? So obviously, x has to equal 8. All right, so that's the end of part 1. I'll jump back here in a second, and we'll go ahead and do part 2.